Hello everyone, we are now going to discuss 5 ML interview questions which are asked very frequently. So these questions can be asked in various forms, but this is the overall answer for all of these questions. So we are going to consider what is the difference between XGBoost and random forest, and this is a very common question which gets asked for various banks also, and also for other IT software related companies. And related to this, another question is which one is more prone to overfitting and why. The next question that we are going to discuss is how do we control overfitting in random forest, and what is the gamma parameter in XGBoost and how does it work. The next question is what is L1 and L2 regularization. Again, a very common question. The next question is how do we detect overfitting, and how do we address it. We are already seeing how do we control overfitting. So partial answer to the last question also lies in question number 2. So the first answer is XGBoost and random forest. Random forest is a bagging technique, whereas XGBoost is a boosting technique. In a bagging technique, there are several models which are working in parallel, whereas in boosting there are uh, there are many models, but these are working sequentially, so that whatever the errors that are made by the previous model are rectified by the next model, and so on. So what we get finally, the final model is what is the sum of all the previous models, whereas in random forest, which is a bagging technique, all these models are applied parallelly. So random forest is one way to reduce variance. So it helps to reduce variance, and XGBoost helps to reduce both bias and variance. Here, XGBoost is more prone to overfitting because of its sequential nature. See, in random forest, many of these are working in parallel, but in XGBoost, what happens is the the prediction of one affects the prediction of the next one, and so on, and that's why it leads to overfitting. And that can be controlled using max depth by specifying gamma, learning rate, or regularization in the hyperparameters of the overfitting in the parameters, and then hyperparameter tuning can also be done for XGBoost. How do we control overfitting in random forest? Now in random forest, see, it is a way to construct a tree. So here I can specify what is the depth of the tree that I am looking at, and I can also specify how many trees are to be constructed. The next parameter which can be specified is max features. So it can specify how many features are to be there per split. The next parameter which can help us to control overfitting in random forest is out of bag error. So now out of bag error is an error which helps us out of bag error helps us when the tree that we are looking at has not when the tree that we are looking at has not seen the data and it still predicts the right error. So so that can help us to evaluate the model performance. So consider if some of the data is not used for a construction of a particular tree, and it gives us an unbiased estimate of the model performance without needing a separate validation test. This is where the OOB error helps us. So wherever that particular tree has not looked into the data, we get the classes and then we compare the actual versus the random. So these are the various ways through which we can control overfitting in random forest. The next is what is gamma in XGBoost. So gamma is a regularization parameter. It helps to understand the loss reduction for a particular split. So more higher is the gamma, more conservative it will be the model. So it will help prevent over complex trees. The trees that we are looking at will not be very complex. It will lead to a simplified model, and so we always want uh, the split to be discarded. That is, I should not continue with the split if whatever gain, information gain that we have is less than the gamma. So it basically helps me with, so this is one parameter which helps me with true tree pruning, and it is also known as minimum split loss. So it indicates what will be the minimum loss reduction for the particular split. So if the split does not reduce the loss, then that split is not going to be made. So we are always looking for a higher gamma value so that the trees do not overfit. Lower gamma value will allow, lower gamma value will give me a more complex model. So I go for a higher gamma value. By default, the value is a 0. The next question is L1 versus L2 regularization. Now L1 considers the sum of absolute weights, whereas, and here feature selection can also be done with the help of L1. Now what happens in L1 is, consider if one feature has the sum to be 0, then in that case that feature completely gets avoided, and so it helps me for feature selection. L2, which is called as the rich regression. L1 is lasso regularization, L2 is rich regularization. Now here it considers the sum of squared weights, and it helps me to shrink the coefficient. There is no feature removal that happens in L2 regularization. And elastic net helps me with both the kinds of regularization. Apart from this, the next is how do we detect overfitting. Now overfitting is a scenario where the tree has understood the patterns, and not just the patterns of the data but also the noise in the data. So here I will get a very good training accuracy, but the test accuracy or the validation accuracy is going to be really poor. So it will increase lot of validation loss, and it will decrease training loss. Training loss or error is going to be less, whereas validation loss is going to be more. So so once we see that the validation, the training accuracy is really good and the test accuracy is low, then we go for handling overfitting. Now to handle overfitting, we make use of cross validation. Now in cross validation, I can specify the cross validation to be 5 or 10. So if I specify it to be, let's say, 5, then the data will be divided into 5 sets, and there will be 5 iterations, and for each iteration one different set will be taken as the test, and all others will be considered for the training. Then regularization, L1, L2 can also be done. Tree pruning can also help me. Drop out means certain features get dropped out. Early stopping, so if there is not lot of improvement that's happening over iterations, then stopping training can be stopped. And then we reduce the complexity, so that by reducing the complexity, the trees do not search for every point, every nook and information, for information in the nook and corner. Uh, Adding more of data and features can also help. So these are the various ways in which overfitting can be handled.